G'day, this is just a video on reciprocal functions, particularly looking at sine, cos and tan, but also using the Pythagorean identity in there as well. So let's get to it. So I guess we looked at the other day the idea of cot, based on our tan things. If we have a look just up here, we had a look at cot theta, which is the same as 1 on tan theta. Okay, so if we start from there, so cot theta is actually cos on sine, which is the same as 1 on tan. We can actually do 1 on sine and 1 on cos as well. So 1 on sine theta we're going to call cosec theta. I think I've mentioned this to you before. And 1 on cos theta is actually going to be called secant or sec theta. Okay, and so we're going to play around with these kinds of rules for in trying to work out both angles and also equations as well. So I'll just jump straight to it with these examples. So sec of 2 pi and 3 is the same as 1 on cos of 2 pi and 3. And then we can just simply do things the way that we would in the past. So cos of 2 pi and 3, you need to know your special triangles pretty well. So that's the same as 1 on a half, although it's negative because it's in the negative quadrant. So therefore, that's the same as 1 divided by negative a half, which is negative 2. I've probably skipped a couple of fraction steps and all that sort of thing in there, but I'm hoping and trusting that you'll be able to work that out by yourself or just work on it a bit more. So this one, cot of 5 pi and 4, I won't write it out again. Cot of 5 pi and 4 is the same as cos of 5 pi and 4 on sine of 5 pi and 4. 5 pi on 4. Now, cos of 5 pi and 4, again using your special triangles, you should work out that cos of 5 pi and 4 is negative 1 on root 2. And sine of 5 pi and 4 is the same, negative 1 on root 2. This is why you need to know your special triangles and your quadrants really, really efficiently. So that divided by that is always going to be 1. Okay, cosec of 7 pi and 4 is the same as 1 on sine of 7 pi and 4. That ends up being sine of 7 pi and 4 is the same as negative 1 on root 2. Okay, and we end up getting 1 divided by 1 on root 2 is the same as just negative root 2. The way I do that, 1 divided by 1 on root 2 is the same as 1 times root 2 on 1. Okay, and we get to that. So those ones should be fairly straightforward, fairly easy. These next ones should be fairly similar. This time we're just working out the angle rather than working out the value, the ratio that they're giving us. So sec is the same as 1 on cos x equals negative 2. So I can say I'm going to switch these two around. So I get negative a half equals cos x. And then you can go and do as you would have done before. So whereas you find the base angle, you find the quadrants, you find the solutions inside the domain. So x should equal 2 pi and 3 and 4 pi and 3. Okay, I've skipped a whole lot of steps there, but hopefully you can see where I've done that, or at least you could do it yourself and work out those. So cot x equals negative 1. That's the same as cos x over sine x equals negative 1. So what I'm going to do is I'm going to do one or two things. I guess I could make that negative 1 over 1. And now I'm going to flip both sides. So sine becomes on the top now. Sine x over cos x equals negative 1 over 1. It's the same. And that's now tan x equals negative 1. When does tan x equal negative 1? Well, that's got to be at 3 pi and 4. And 7 pi and 4, obviously inside the domain of 0 to 2 pi. Another part of this topic is to use the Pythagorean identity of cos squared plus sine squared equals 1 to work out these kinds of questions here. So cosec x equals 7 on 4, find cos x. Cosec x is the same as 1 on sine of 7 on 4. I'm going to make that sine x equals 4 on 7. Now I want cos x, not sine x. There's two ways that I can work this out. One is that I can just draw a little triangle, because sine means opposite over hypotenuse. So x is the angle, opposite is 4, hypotenuse is 7. So I'm going to find out what this y is here. So y squared equals 7 squared minus 4 squared, which is the same as the square root of 49 minus 16, which is root 33. So therefore, if I want to find out cos x, which is just the adjacent over the hypotenuse, that's just root 33 on 7. Done. Let me show you another way to do this kind of question. Over here, I'll do b. That's the same as 1 on cos x equals negative 3 on 2. We'll flip everything, so cos x equals negative 2 on 3. If cos x equals that, I know that sine squared x plus cos squared x equals 1. So therefore, sine squared x equals, one more step, plus negative 2 over 3 squared equals 1. Sine squared x equals 1 minus 4 over 9, which is 5 over 9. Now I get sine x equals positive or negative root 5 over 9. How do I know whether it's positive or negative? Well, it says that it's in this quadrant, and it's sine, so therefore it's positive in that quadrant. Sine x must be positive root 5 over 3, because the root 9 ends up being 3. I think I'm going to skip over question 8. Again, we're just using sine squared plus cos squared equals 1. I want to do question 9 because I think that one will be a little bit tricky for people. Essentially, this is where we're going with this topic, both now and into the next exercise as well. We're doing a little bit of proving that one side equals the other side. So often what we can do is we can call this the left-hand side and this the right-hand side. And sometimes you're going to do something to the left-hand side and stop, and then you might do a little bit to the right-hand side and end up getting the same thing, and then say, well, they're done. Left-hand side equals right-hand side. Sometimes you work only on the left-hand side, make it equal the right-hand side. Sometimes you do the opposite. So I'm going to start with the left-hand side, just because I don't like fractions. What I'm going to do is I'm going to get a common denominator of the bottom here. Now, if I had, say, 4 over 7 and 2 over 3, change that, make it 1 and 1. The way you'd work that out is you'd probably multiply the bottoms together and then multiply therefore the top 1 times 3 and the other top 1 times 7. So you end up getting 10 over 21. Okay, that's what I'm going to do here. I'm going to multiply the bottoms together, so I get 1 minus cos theta, 1 plus cos theta, and I get 1 plus cos theta up the top, plus 1 minus cos theta. Cos theta and negative cos theta cancel, so all I end up getting on the top is 2. And what do I get down the bottom? I get 1 plus cos theta minus cos theta minus cos squared theta. So this is all the left-hand side. Left-hand side equals all of that. 1 minus cos squared theta is the same as sine squared theta. And sine squared theta is the same as cosec squared theta. And I've proved. Sometimes we write QED, which I think is Latin. Can someone tell me what that means? Anyway, we ended up getting the left-hand side equal the right-hand side. So we're done. So hopefully that has helped you with these questions from 14C. You can have a look at the other videos to do the compound and double angle formulas as well. So that's the next topic. So thanks very much for watching.